Okay, hello ladies and gentlemen. All right, so what we're going to do today is we're going to talk about what is standard deviation and how it relates to what we're doing in class. Okay, notice what we've talked about today, or what we have already referred to, is right here you have three medians, or I'm sorry, means, averages, which we call X bar now. Now, I want you to notice this data is very close to the average. This data is a little bit more spread out, and this data is very spread out with regards to the X bar or the average or mean. Whenever you have data that's close together, you're going to have a small standard deviation. All right, smaller standard deviation. And remember, deviation, based on up here, it basically measures the spread, looking at basically the distance from the mean, from the average. Okay, so as this data gets more spread out, the standard deviation is going to get larger. Now, out of all three of these, this standard deviation is going to be the largest because the data is the furthest away from the average or from the mean. This data is still spread out, but the standard deviation is going to be less than C, but it's going to be more than A. And finally, again, A is going to have the smallest standard deviation. All right, when we try to figure out what standard deviation is, it actually has a formula. All right, standard deviation is the square root of the sum of, you take each observation, which we learned is your data, you subtract the average, or X bar, and then you square it. And you do that for every single piece of data that you have. And notice how they have the plus, then it's dot, 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 plus. That means there's more in between here. So however many pieces of data, we do this too. We then take the number of pieces of data that we have, subtract it from 1, and that's what you divide this by. So you're finding the sum of all these on top and divide them by n minus 1, and then you take the square root, and that is standard deviation. And let's practice some of this, okay? Now, first of all, one of the first things I'm going to have you do is make a dot plot. All right, so first of all, here's 3, 5, 5, 7, 8, 2, 7, and 5. 7 and 5. Now notice there's a concentration here. What I want to do is I want to find, there are 1, 2, 3, 4, 8 pieces of data. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 pieces of data. Now, X bar, remember this is your average. So this is your average. It's also called mean. All right? So those two, any of those three terms. The average in this case, we add up all these numbers and we divide by however many you have. So this adds up to 42, and we divide that by 8, and we get a average of 5.25. Now, once you do that, you're going to come over here and you're going to complete the table to the right, okay? So that's the next step, complete the table to the right. So what I'm going to do in this table is I'm going to fill in all my values right here for x. So, and I'm going to put them in order. So I want to put them in order. So 2, I'm going to use the dot plot. 3, 5, 5, 5, because there's 3 5s here. 7, 7, and 8. And what you want to do is you're going to take each number and you're going to subtract the average. So here it would be 2 minus 5.25. Here it would be 3 minus 5.25. And you would do that all the way down till you get to 8. All right? Now this happens to be negative 3.25. This happens to be negative 2.25 and negative 0.25, and this happens to be negative 0.25, negative 0.25. This is 1.75, 1.75, and 2.75. So as you can see, I've already calculated these. Now, the next thing you're going to do is, this is x minus your average, this data right here. Well, what you're going to do now is you're going to square that. And what that does, when you square it, that makes this positive. So negative 3.25 squared, so if I negative 3.25 squared, that's going to give me 10.5625. Now notice I went 4 decimal places. All right, I want you to be fairly accurate with this. So I'm going to go 4 decimal places. If I do negative 2.25, well, that's going to be 5.0625. And now I've already done these for you, so we're just going to go ahead and put these through. So 0.0625. So again, like I said, I'm squaring these numbers, making them all positive. 3.0625, 3.0625, and then finally 7.5625. Now, once you have all these things here, let's go back to the formula here. Remember, the formula said we're going to take the sum of all these. So now that last column, we're going to add each individual number. So I want you to add up all these numbers here. All right? And that's what this is. That's what this is. This is the sum of all these. And this happens to be 29.5. 29.5. So I've added all these up and I get 29.5. Well, once you do that, you're going to come back over here and this is the sum. So 29.5. That's the sum of that last column. That's what that E, that sigma stands for. It means sum. All right, let's increase this size a little bit more. All right, now variance. Now there's a little box up here. I didn't go over it. I just kind of skimmed over it. So S squared. So when you take this, whenever you find the standard deviation, that is called the variance. The variance is basically the standard deviation squared. You're going to need to know that. So before we take the square root, this is actually your variance. All right? So, or actually, this is part of your variance. So what we're going to do is 29.5, and we're going to divide it by n minus 1. Well, so we're going to have 29.5. We're going to do, n happens to be 8. So we're going to do 8 minus 1, which is 7. So 8, right here. And we're going to put in this formula here. So subtract 1, 7. So 29.5 divided by 7 happens to be 4.2143. And we'll talk about what variance means later on. Now, to figure out standard deviation, all right, the long way of doing it is I have to take the square root of, and let me just minimize this a little bit. What you would do is you take this 10.5625, 10.5625 plus 5.0625 plus dot dot dot, go all the way down to this one, 7.562 plus 7.5625. Notice I abbreviated it, but I would have to add all those together, and then I'm going to divide by n minus 1, which was that 7. Now notice, I've already added all these together, so this is actually the square root of 29.5 divided by 7, which I've already calculated, which is the variance. So I have the square root of 4.2143. Now, notice this is all the square root. So I haven't found the standard deviation yet. So when I take the square root of 4.2143 here, which is my variance, I end up getting 2.0529. Now, what we've done here is we have our mean. This is our mean of 5.25. What we're going to do is we're going to add 2.0529. Right? We're going to add that 3 times to either side, and we'll go over that the next day in class. And that concludes how you do this chart.